When you have a system of equations that's linear quadratic, a straight line and a parabola, here are 3 examples. The first one, y equals 4x plus 3, y equals 2x squared plus 8x plus 3. I'm going to find a graph of that. Here it is. This is the graph of the first one, and it has 2 solutions. So the solutions are 0, 3, and -2, -5, or x equals 0, y equals 3, and x equals -2, x equals -5. We actually need to keep those answers together. There are 2 values for x and 2 values for y, but we can't mix them up. So the x value of 0 has to go with the y value of 3. And the x value of -2 has to go with the y value of -5. So we couldn't say x is 0 and y is -5. That doesn't work. It has to be those specific things. But there's 2 solutions. So that's one possibility. And then somebody said there were other possibilities. So the second one here, y equals x squared and y equals 2x minus 1. Let me see if I can find that one. Hopefully it's just the next one here. Yep. That's it, y equals x squared and y equals 2x minus 1. And that has only one solution. There's one solution when the line is tangent to the curve. And what tangent to the curve means is it touches it only in one spot. So it's only touching the curve right there at 1, 1. So x equals 1, y equals 1, and that's the only solution. And then the third possibility you guys said was no solution. So you can probably picture what that might look like, but let's look at one. So this one, y equals x squared minus 2 and y equals 1/2 x minus 5 has no solution. The line and the parabola don't intersect at all. So you could have 0 solutions, 1 solution, or 2 solutions. Those are the only possibilities when you have a linear quadratic system. So here's the other possibility for quadratic systems. Y equals x squared plus 2, y equals -x squared plus 2x plus 6. This is one where one is opening up and one is opening down, right? And let's see. That's not the right graph. That might be it. That looks like the right graph, doesn't it? So this one has 2 solutions, and that's probably what you're going to find most often when you're working with quadratic systems, is 2 solutions. The next one has 2 both opening up, x squared minus 4x plus 7, and 1/2 x squared minus 2x plus 3, and that looks like this and has no solution. Those 2 don't intersect at all. They're both going to continue to get wider as it goes up. So like the orange one will never meet up with the black line there. No solution. And that'll happen sometimes. And then the last one, x squared plus 4 and -x squared plus 4. That's this one. One's opening up, one's opening down, but they intersect just at one point. So 1 solution. And the one that I am not showing you here is an infinite number of solutions where the 2 equations are exactly the same, or one is a multiple of the other, right? If you take the equation and you multiply every term by a certain number, then it makes the same graph, as long as it's multiplying every term. So if they're exactly the same or one's a multiple of the other, then there'll be an infinite number of solutions. Solving algebraically, we're going to use elimination for this one. The only thing when you're solving, what kind of system is this? Quadratic. If you're going to solve by elimination or substitution, you probably, for most of the ones you're going to do, are going to have to either substitute or eliminate the y's. And the reason is, with a quadratic, you have x squareds and x's most of the time. So if we eliminate the x squareds, we don't eliminate the x's. And if we eliminate the x's, we don't eliminate the x squareds. And so you don't end up with something that you can solve. But if you eliminate the y's, then you have x squareds and x's, and it will be something that you can solve. So for elimination here, we're going to eliminate the y's. And what do we have to multiply the equations by to eliminate the y's? 4, or maybe -4. Should I do this one by -4? And the second one? Nothing. 1 or nothing, right? So this will become 16x squared plus 4y plus 8x equals 20. And oops, I don't want that yet. Well, I guess I could because I'm not actually changing the second one, but I'll rewrite it anyway. Because I'm going to rewrite it because I want it to line up the same as the other. So let's change actually the first one. I'm going to change this to be minus 20 equals 0. Is that okay? So it was equals 20, but I moved it to the other side. The reason that I moved the 20 over and made it a negative 20 here was just I want everything to line up when I add them together, and also I know it's going to be quadratic, so I want everything on one side to be able to solve it. So now I get, when I add those together, 19x squared. The y's are gone, minus, how many x's is that? 38? And minus 57? Now I have a quadratic, and we know how to solve a quadratic, factoring or quadratic formula, since we're solving algebraically. But does that have a common factor that I can remove? 19. Is 19 a common factor?
Yeah.
I think it is. Yeah, so let's take out the 19 first. This will be x squared minus 2x minus 3. Is that right?
Yeah.
Okay, so now I can factor that, which is much easier to factor than the first one. Make sure you look for that common factor. If you didn't notice it, trying to factor that would be difficult. So this is going to be, I'll just leave the 19 there. X, 3, 1, negative, positive. X minus 3 and x plus 1. So what I get for answers here are x equals 3 and x equals negative 1. So this one has 2 solutions, but I'm not finished yet, right? When you're doing elimination, you then have to go back and find out what y is equal to. And we're going to have to figure out what y is equal to for both values of x. Now to figure out y, I'm going to do negative 4 times 3 squared minus y minus 2 times 3 equals negative 5. So I replace both x's in that first equation with 3. And let's see what that works out to. Negative 4 times 9, that's negative 36.
Yeah.
Minus y minus 6 equals negative 5. So I think I'll bring the 5 over by adding 5 to both sides, and I'll take the y to the other side, since y is negative and I want it positive. So I'll add y to both sides. The y goes over there, and I'll add 5. So I get negative 36 minus 6 plus 5, and I end up with y equals negative 37. So what that means is that one point of intersection is at 3 and negative 37. And that's the way I'm going to write my answer, is as an ordered pair, because 3 has to stay with negative 37, like I mentioned before. Those two go together. When x is equal to 3, y is equal to negative 37. And then I'll do the same thing using negative 1. So negative 4 times negative 1 squared minus y minus 2 times negative 1 equals negative 5. And I get negative 4 minus y plus 2 equals negative 5. So I'll do the same thing, move the y over here, add 5 on that side, so it's negative 4 plus 2 plus 5. And I get y equals negative 5?
No.
3?
Yeah. No.
3. So my other point then is negative 1, 3, the x value and then the y value. And those are the solutions. I have just one more example for you. It's this. I'm going to use substitution. This is, what type of system is this? Linear quadratic. One linear equation, one quadratic equation. And usually when I have a linear quadratic, I'm going to use substitution. Again, not always, but it usually works out easier because when you do elimination, you know, you want to line up everything that's the same, like the x's under the x's, the y's under the y's, and so on. But you don't have anything to line up with the x squareds. That's why I like substitution for this. Also, this one, it's easy to isolate the y in the second equation. If I isolate the y, I have y equals negative 2 plus 2x. So just add 2x to both sides. And then I can fill that in. And this is what y is equal to. So this is where I'm going to put it in the other equation where we have a y. So x squared minus negative 2 plus 2x minus 2x equals negative 2. Expand and simplify. This is a quadratic. So I want to also have everything on one side. X squared plus 2 minus 2x minus 2x. And I'll say plus 2 equals 0. So I took that negative 2 and moved it over here as a plus 2. And when I combine like terms, x squared minus 4x plus 4 equals 0. Now I have a quadratic that I can solve by factoring. X minus 2 and x minus 2. Yeah, so what does x equal? 2. How many solutions does this one have? Only one solution. Because x equals 2 from this factor, x equals 2 from this factor. So there's only one solution. And then I still need to find the y value, but we know y equals negative 2 plus 2x, so y equals negative 2 plus 2 times 2, because x is 2. That's a lot of 2's. And this comes out to y equals 2. So the answer is 2 and 2 if you're writing it as an ordered pair.